So on Discord too. So if you have access to Discord, and I can see that I am there as well, g'day to Graham and Ian that have tuned in. And very last minute here, I've had all day to get this right, and right now we're just managing to get this sorted out as I speak. So we do have another camera here too. I've just recently installed a new JVC camera. Let's see if I can find that on the scheme of things. I think it was input number 3. So I shall just, no, it's not that one. Must be my 4th camera input. So let me just find my camera here. There it is. And that should bring up the one that's face onto me there, which is that fellow. So yes, I think that's all working. And I'll have to reinstall my other camera because I selected it, it decided to lock up. So I'm just going to have to close that down quickly and then open it up again, just the way vMix likes to work. Where was that now? I think it was the 3rd input. So should we get ready to go? There it is, and there's the 2 cameras that I can select from. That'll do for the moment. Apologies for not being around last week, but we had a bit of a cold that hit us last Friday, and that affected the vocal cords to some degree, but partly because I had some overtime occurring last week. So it's been about 6 or 7 years since we had overtime in this side of town, so I wasn't going to say no to that. So yeah, it's actually been all this week. In fact, 6 o'clock starts all this week, so I figured it'd be a good idea to get an early night. Oh, pardon me. All right. We've got a few things tonight, but hopefully we can get it all through by 11 o'clock. Oh, there was something else, but it's okay. I've got a solar report from Timothy Scove, our space weather woman, and what just came to mind just then was that Timothy is making a presentation down at Tasmania this coming week, I think it is. I was going to look that up and have the date ready here to say, but it was on the broadcast the WIA broadcast last Sunday. There was a reference to I think it's called a Hamicon down at Tasmania at the Reist Radio Club, and they've got Timothy all booked up to do a presentation. Now I'm not 100% sure whether she's going to be there in person or whether she's doing this via Zoom or some other method. I was hoping, like I say, to have a quick look at the website, the Reist website on that one. But anyway, she's going to make an appearance down there nevertheless. But we do have a report. She's just released that within the last 24 hours, so it's pretty current, which is good to have. Okay. Now, excuse the noise of the traffic outside. Let me see. Just because I've lost 1 week, everything's out of shape here. Just for those that don't know, oops, just get this right. The ASV is a non-profit society for people interested in astronomy, attracting and catering for people from a wide range of ages and backgrounds, abilities and interests. First formed in 1922, the society has grown to over 1,000 members. Its activities are coordinated by a council of elected office bearers, section directors and ordinary councillors. The ASV has weekly activities at our 2 metropolitan locations, a place called the Morley Community Village and the Melbourne Observatory. And we host monthly Astro Talks at the Herbarium near the Melbourne Observatory. The Society's library is located at the Melbourne Observatory and is open during our Astro Talks. For over 50 years, the ASV has played a major role in the care of buildings and facilities at the Melbourne Observatory. Our members conduct astronomy for the people gatherings throughout the year, bringing telescopes and astronomy to Melbourne's parks and schools. Please check the calendar on the website for details if you are interested in attending one of these events. The ASV is currently involved in a number of major projects. We are involved in the restoration of the Great Melbourne Telescope and also currently working on the installation of a series of remote telescopes at the Dark Sky site north of Heathcote, which once completed will be available or accessible to our members for use. Thanks to a generous donation from one of its most long-standing and respected members, the Leon Mao Dark Sky site located north of Melbourne has a pristine night sky for deep sky observing. The ASV has a 25-inch telescope, a 40-inch telescope, and a wheelchair-accessible 16-inch telescope at the Leon Mao Dark Sky site, and makes use of the existing telescopes at the Melbourne Observatory during some section meetings and our members' night held once at the Melbourne Observatory. There's also an annual yearbook which is supplied to members, as well as a bi-monthly newsletter called Crux, which all members are welcome to contribute to. There's also an email newsletter that gets sent out every other week just to keep members abreast of what's coming up and anything new or any updates or changes that might occur that needs the membership to be known pretty quickly. The ASV's logo, which shows the Southern Cross and the pointer stars, is something in Latin which I can't pronounce, but it is translated as "this way to the stars." The ASV is governed by a set of rules which should be read before applying for membership. Pretty important, I think, to do that. This document may be downloaded from the website as well. Any person or organisation with an interest in astronomy may apply for membership of the Society. And the website to go to is www.asv.org.au, and all will be revealed. Membership is via PayPal, all fairly easy to do, and once you've joined up with the membership, within a week you should receive a membership pack, which will give you various bits of information required, necessary, and all that sort of stuff. Alrighty then, that was the rundown for the Society, of which this broadcast is on behalf of. Been running since 1988. Okay, and it looks like I'm on Discord. I can see VK3TJS is there as well. All very good. Let me just minimize that. That's on Discord. If you wish to look at the HD stream on Discord, just visit the qrz.com page for this station. VK3 Echo Kilo Hotel, VK3 EKH on qrz.com. I provide a link to allow you to be able to see the HD stream, or the chat room for that matter. But of course, the first thing you have to do is register with Discord, and it's a little bit of a process involved. There's no money filed, there's no fees or anything like that. Just register on the Discord website. They'll want a few little details about you, nothing too critical. But once that appears to have gone through, then you click on that link that I provide on the qrz.com page there, and you should be able to immediately go to this particular location. Anyway, there it is. You're tuned to VK3 EKH, the official station of the Astronomical Society of Victoria. Righto. Now, like I say, I've only got less than a handful of things tonight, but all of some interest, and all requiring some sort of video application, i.e. To look at the Melbourne TV repeater, to look at or try to look at the Melbourne television repeater, and also my YouTube stream, which I hope is still working. Yes, it seems to be still hanging in there. Okay. This first article, courtesy of Astronomical.com, starts off by saying, why does Earth have only one moon? A physics expert explains why Earth has only one moon while other planets have hundreds. This was published on June 24, and it is courtesy of Astronomy.com. I think there's just one. Oh yes, there's two little diagrams to show here. So the question was asked, why do some planets have moons and some don't? On Earth, you can look up at the night and see the moon shining bright from hundreds of thousands of miles away. But if you went to Venus, that wouldn't be the case. Not every planet has a moon. So why do some planets have several moons while others none? The person writing this article says, I'm a physics instructor who has followed the current theories that describe why some planets have moons and some don't. First, a moon is called a natural satellite. Astronomers refer to satellites as objects in space that orbit larger bodies. Since a moon isn't human-made, it's a natural satellite. Currently, there are two main theories for why some planets have moons, and moons are either gravitationally captured if they are within what's called a planet's Hill sphere radius, or they're formed along with a solar system. Objects exert a gravitational force of attraction on other nearby objects. The larger the object is, the greater the force of attraction. This gravitational force is the reason we all stay grounded to Earth instead of floating away, and why there's also an atmosphere, partly why the atmosphere is maintained at least. The solar system is dominated by the Sun's large gravitational force, which keeps all the planets in orbit. The Sun is the most massive object in our solar system, which means it has the most gravitational influence on objects such as planets. In order for a satellite to orbit a planet, it has to be close enough for the planet to exert enough force to keep it in orbit. The minimum distance for a planet to keep a satellite in orbit is called the Hill sphere radius. And there's a little diagram here which I shall bring up that kind of shows this to some degree. The Hill sphere radius is based on the mass of both the larger object and the smaller object. The moon orbiting Earth is a good example of how the Hill sphere radius works. The Earth orbits around the Sun, but the moon is close enough to Earth that the Earth's gravitational pull captures it. The moon orbits around Earth rather than the Sun because it is within the Earth's Hill sphere radius, as seen in the diagram here. Small planets like Mercury and Venus have a tiny Hill sphere radius since they can't exert a large gravitational pull. Any potential moons would likely get pulled in by the Sun instead. Many scientists are still looking to see whether these planets may have had small moons in the past. Back during the formation of the solar system, they may have had moons that got knocked away by collisions from other objects. Mars has two moons, Phobos and Deimos. Scientists still debate whether these came from asteroids that passed close into Mars's Hill sphere radius and got captured by the planet, or if they were formed at the same time as the solar system. More evidence supports the first theory. because Mars is close to the asteroid belt. Jupiter, Saturn, Uranus and Neptune have larger Hill sphere radii because they are much larger than Earth, Mars, Mercury and Venus, and they are farther from the Sun. Their gravitational pulls can attract and keep more natural satellites such as moons in orbit. For example, Jupiter has 95 moons while Saturn has 146. Another theory suggests that some moons formed at the same time as the solar system. Solar systems start out with a big disk of gas rotating around a sun. As the gas rotates around the sun, it condenses into planets and moons that rotate around them. The planets and the moons then rotate in the same direction. But only few moons in our solar system were likely created this way. Scientists predict that Jupiter and Saturn's inner moons formed during the emergence of our solar system because they are so old. The rest of the moons in our solar system, including Jupiter and Saturn's outer moons, were probably gravitationally captured by their planets. Earth's moon is special because it likely formed in a different way. Scientists believe that long ago a large Mars-sized object collided with Earth, and there is a kind of a computer simulation here, which I've done a certain trick to be able to see this, so let's see if this works while I'm saying this. Okay, I'll just loop that. So what you're seeing on the screen now is this computer simulation. So during that collision, a big chunk flew off the Earth and into its orbit and became the Moon. That's kind of what's being illustrated there on the screen. Scientists guess that the Moon formed this way because they have found a type of rock called basalt in soil in the Moon's surface. The Moon's basalt looks the same as basalt found inside the Earth. Ultimately, the question of why some planets have moons is still widely debated, but factors such as a planet-sized gravitational pull, Hill sphere's radius, and how its solar system formed may play a role. So that computer simulation just seeing rolling along it there is pretty much how we all think it came about. Something collided with Earth when it was forming, and as a result, a certain mass was freed up and allowed to be captured by the Hill radius of our planet, and it became our moon. And thank goodness for that. Without this moon, things would be somewhat different on our planet in more ways than one. So most interesting indeed. So thank you, NASA, for that. Alright, you're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Struth. Okay, now, keeping within the moon theme, and there's a reason for this, why I talked about our moon. It appears that Earth will capture a second moon this weekend, some scientists say, published 17 hours ago, probably 18 hours ago now, courtesy of space.com. Earth will get a second moon this weekend, but it won't be sticking around for very long. NASA scientists have calculated that the Earth will capture a second moon on Sunday, September 29. The mini-moon comes in the form of a tiny asteroid 2024 PT5, which usually orbits the Sun as part of a small asteroid belt that follows the Earth. While Earth's primary companion, the Moon, has lingered around our planet for around 4 billion years since its formation in the solar system, infancy, this asteroid will be a temporary fixture that won't even see the year out. According to the latest data available from NASA's Jet Propulsion Laboratory, NASA's Horizons system, the temporary capture will start at around 1954 UTC and will end 1543 UTC on November 25. So that's from Sunday, for 1954 UTC Sunday, and will end 1543 UTC on November 25. The mini-moon event expert and what's this word? It's a whole lot of something in Spanish here. What are they saying here? I don't know, some professor in a university in Spain. Anyway, I'll continue on. The object that is going to pay us a visit belongs to the Arjuna asteroid belt. Arjuna asteroid belt, a secondary asteroid belt made of space rocks that follow orbits very similar to that of Earth at the average distance to the Sun of about 93 million miles or 150 million kilometers. Marcos told Space.com last week, and this is the professor, Marcos, that objects in the Arjuna asteroid belt are part of the near-Earth orbit population of asteroids and comets. Though the idea of Earth getting a second moon sounds extraordinary, these gravitational capture events are actually quite common. And some Arjuna asteroid belt objects can approach Earth at a close range of about 2.8 million miles or 4.5 million kilometers, and at a relatively low velocity of less than 2,200 miles per hour or 3,540 kilometers an hour, Marcos explained. Asteroid 2024 PT5 will not describe a full orbit around Earth. You may say that if a true satellite is like a customer buying goods inside a store, objects like 2024 PT5 are window shoppers. After its brief stay around Earth, the asteroid 24 PT5 will continue to orbit the Sun as part of the Arjuna family of asteroids. 2024 PT5 isn't the first asteroid to be captured by the Earth to be transformed into a mini-moon. Scientists have officially documented 2 prior short captures, a type of asteroid grabbing event lasting about a week and estimated to occur several times per decade. We also know of 2 prior rarer long capture events that can last years rather than weeks, that led to snared asteroids completing for one or more full orbits of Earth. The fact that asteroid 2024 PT5 will stick around for just a few weeks as opposed to billions of years isn't the only major difference between this mini-moon and the actual moon. Whereas the moon dominates the night sky over the Earth for at least half the month, 2024 PT5 won't be observable to the average sky watcher. However, professional astronomers may be able to grab us some images of this temporary alignment. This is mostly due to the massive difference in size between the 2 bodies. While the moon is estimated at 3,475 kilometers in diameter, 2024 PT5 is believed to be just 37 feet wide, and that means that the moon is a whopping 308,000 odd times wider than the lunar Pretender asteroid at 2024 PT5. Gee, you have to read that a few times. The object is too small otherwise, is what we're trying to say, and dim for the typical amateur telescopes and binoculars. However, the object is still well within the brightness range of a typical telescope used by professional astronomers, Marcos concluded. A telescope with a diameter of at least 30 inches plus a CCD camera detector is needed to observe this object. A 30-inch telescope with a human eye behind it will not be enough. So actually, that's what I figured. I think the only way to be able to see this moon would be to be able to capture it over a, say, two or three night event, so that in this, as you know, where the object is in the sky, you take 2 or 3 images of the same part of the sky over 3 nights, and what you're looking for is that one object amongst the starry background that actually is moving, and that's it. That'll be it. So to all the astrophotographers out there, there's your challenge to get that captured event of this asteroid 2024 PT5 this coming week. I want to see pictures for next Friday, okay? You're tuned to, sorry, I just realised I haven't got my little caption up on the screen there. You're tuned to ASV Radio VK3EKH. Let me just visit my ID information. There we are. That's what should have been up on the screen. Now, having that out of the way, this is something of a little bit of interest. Quite some time ago, in the year 2007, I'm trying now to key up this article. Where are we with this? There we are. Good. Okay. Yep. So, at 10:28 past the hour, I also forgot to mention there is an email address you can write to me to, vk3ekh at gmail.com, vk3ekh at gmail.com, which I think I've got actually up here on the screen. And we have 2 folks that have actually sent me emails. G'day, Andrew, VK3KIS. And I think John is listening as well. G'day, John DeKaiser. I haven't seen or heard you for ages, but thank you for emailing me there. He's listening on 3541 kilohertz via the Kiwi SDR. I wonder if that's Paul's Kiwi SDR. Anyway, g'day, guys. All right, minimise that. Now, yes, back in 2007, we had a comet visit the skies, which was predominantly visible in Melbourne at the time, and it was called Comet McNaught, also known as the Great Comet of 2007, and given the destination C/2006 P1, is a non-periodic comet discovered on 7th of August 2006 by British Australian astronomer Robert H. McNaught using the Uppsala Southern Schmidt telescope. It was the brightest comet in over 40 years and was easily visible to the naked eye for observers in the southern hemisphere in January and February of 2007. Do you remember going outside and looking for it? Well, I did. The only camera that I had available to me at the time was a Sony video camera. And for those folks that are watching TV, you might see me holding up this camera. No, which camera? There we are. So this camera was my first acquisition of a digital type camera, although it uses DV mini cassettes, so it's sort of analog digital format. Very expensive camera for its time, but I set that up on a tripod in the backyard because this comet was so fully visible due south, looking towards Frankston from where I was living in Dandenong. And I set the camera up, and I've managed, after all these years, I've managed to find the video cassette that has this video on it. It's one of these cassettes here. And I've managed to download the video onto the hard drive here. And if all works well, I should be able to just run this video while I'm talking. And is it playing? I'll make it play. There we go. All right. So you're going to have to look pretty hard on the TV, but you should be able to see it. It'll come good in a minute. I do a few close-ups of it, and the CCD camera becomes a little bit more sensitive to the night as the sun goes down, because the sun's only in the process of still setting in this image. But if you look hard enough on the screen right now, you can pretty much see this little fuzzy ball on the screen. And I was fairly impressed to be able to get this vision, this live video of this comet. Yeah, so it was, like I say, it was considered the brightest comet in over 40 years, and it was easily visible to the naked eye. It had an estimated peak amplitude of minus 5.5. The comet was the second brightest since 1935. What else can I say here? McNaught discovered the comet in a CCD image on the 7th of August in 2006 during the course of routine observations from the Siding Spring survey, which searched for near-Earth objects that might represent a collision threat to Earth. The comet was discovered in Orpheus, I think that's how you pronounce that, shining very dimly at magnitude of about plus 17. From August through November 2006, the comet was imaged and tracked as it moved through Orpheus and Scorpius, brightening as high as magnitude plus 9, still too dim to be seen with the unaided eye, but then for most of December the comet was lost in the glare of the sun. Upon recovery, it became apparent that the comet was brightening very fast, reaching naked eye visibility in early January 2007, which is, again, you can see on the camera now, fairly visible there. Yes, whereas the comet was dubbed the Great Comet of 2007 by Space.com, after passing the sun, McNaught became visible in the southern hemisphere in Australia, according to the Siding Spring Observatory, where the comet was discovered. What else do we say here? And its period, it took Comet C 2006 P1 took millions of years coming directly from the Oort cloud. It follows a hyperbolic trajectory, and during its passage through the inner solar system, it will leave the influence of the planets and remain bounded to the solar system as an Oort cloud object or comet. Given the orbital nature of the object, different epochs can generate quite different heliocentric two-body best fit solutions to the orbit time. For objects such as this one, they reckon that the orbital period is in the vicinity of approximately 92,700 years, if I read that correctly. So it's it won't be seen again in the near future. So if you want more information about that, I just read that from the Wikipedia site for Comet McNaught. But apart from all that, it makes filming it on videotape, as you can see on the screen there, fairly good to actually have that. I'm glad that the video still plays quite well, and that I was able to put that down on the hard drive, so it's now in safer. In safer territory. Looking on the screen right now, looking off the repeater, it looks quite good. You can actually see a tail quite distinctly, and the gaseous ball there. So there it is, Comet McNaught, filmed around the 15th of January, I think it was, 2007. So fairly excellent to have that, I imagine. Very good, isn't it? You're tuned to ASV Radio, VK3EKH. Now, I think what we shall do is go across to Tamitha's solar report. Let me just see if I can find her video. I'll just bring up the caption there. And stand by for Tamitha. If I can just find her video. I know it's just here. There it is. Okay, there she blows. And alright, stand by for Tamitha. Let's hope this works. I just got my doubts about my system here, really do. Alright, stand by.
We have some fast solar wind hitting now with a solar storm chaser, and some returning regions on the east limb could bump up activity. Those stories and more are in this week's Spotlight. If you want to learn how weather from our star causes impacts at the Earth that shape the future of our world, join Professors Dr. Jenny Meehan, Michael Cook, and myself as we guide you through a space weather certificate program like no other. To enroll in the Space Weather and Environment Science program offered at Millersville University, go to millersville.edu/SWEN. It's weather for the 21st century. This forecast also sponsored in part by CW Ops. Space weather this week stays a bit on the mild side. As we take a look at our Earth-facing disk, we do have a lot of active regions in Earth view, but they're kind of in a holding pattern. They really haven't been firing off any big flares. In actuality, the biggest activity we've gotten is from fast wind from this coronal hole that's rotating in through the Earth strike zone. The fast wind it's sending has actually managed to bring us aurora clear down to mid-latitudes, likely because we're really close to the equinox, so the impacts end up being quite larger. But the nice thing is that we do actually have one active region. This is region 3834 and 3835, kind of this cluster of stuff here. This one back on the 22nd fired, wham, right there. A beautiful solar storm launch right there. You can see it looks very much like it's going to be going to the east of Earth. But when we take a look at it in coronagraphs, you can see this partial halo. Let me try to pull it up just a little bit more. Whereas it actually looks, you can see it kind of going all the way around the sun like this. It was an asymmetric halo, but that does mean that part of it is Earth directed. And so this solar storm is going to be chasing that fast solar wind and be hitting us really any time now. But since then, it kind of destabilized this filament and destabilized that filament, but we still haven't seen them launch. They're still holding on as well. So what we've really been paying attention to is region 3836. This is the region that's just beginning to rotate into view. We even have a couple regions after that that we're watching as well. But when we take a closer look at the activity that's going on with this region, we can pull up here in magnetic field imaging. You can actually see as this thing gets closer into focus, as it rotates further into view, you can see all of this red region in here, and then you see this blue and white region. And take a look at these little fingers of red that are poking up into the blue and white. That's showing that this region really could be a big flare player. So we've been watching it very closely because it sure looks like activity could be picking up from these regions here in the next few days. Now, switching back to that solar storm that's Earth directed, we switch to our solar storm prediction model, ENLIL. Now, this is NOAA's version of the model. The top panel's density, the bottom panel's velocity. You're looking down at the sun from the North Pole with Earth being off to the right. And when we set this solar storm model in motion, you can actually see that solar storm launching mainly to the east of Earth. You can see it's quite long here, but it does have a finger that extends upward along the Earth-Sun line. So it looks like we're going to just get grazed by this solar storm. NOAA had predicted that this storm would impact us early on the 25th. That has not happened, likely because of this fast wind stream right here. You can actually see the density plug here that kind of acts as like a brick wall. You can see a little bit of that fast wind stream here. That is likely slowing down this solar storm, so we kind of have to wait for that fast solar wind to wane just a little bit before this solar storm hits us. So we're expecting it later on today. Now, as we take a look at the NOAA version of the model, again, we're looking down at the sun from the North Pole with Earth being off to the right. You're going to see this solar storm launch, but if you look very closely, closely, I'm actually showing the shock wave in front of that solar storm. Yes, NASA actually models the shock as well as the bulk of the solar storm. And as we pull it out, you can see we actually get a bigger hit from the shock itself. This is the part that we've been kind of waiting for to come. It is on the late side, but it still looks like the shock is coming. The bulk of this structure will hit us late on the 25th, but more likely into the 26th because it's being delayed again by this fast solar wind stream that we have just ahead of it. So aurora photographers, if you're at mid-latitudes, you might even be enjoying a bit of fun from the fast solar wind, but we could get a plus up in activity once that solar storm hits. We could even see G2 levels before things begin to calm down. So expect to keep your batteries charged, but stay on your toes because this storm could hit at any minute. So what else does our sun have in store for us this week? Well, to determine that, we go to our full sun map that utilizes SDO AIA imagery for the sun's front side and solar orbiter EUI imagery on the sun's far side to get an idea of what active regions might be lurking there. And to orient you, if I set this in motion, you can see here's the east limb of the sun in Earth view, and here's region 3834 and 3835. These were the regions that fired off that Earth-directed solar storm that we're waiting for. But as we look past that, back around on the 20th and 21st, here's what will be region 3836. You can see it's got some activity here, but take a look at region 3811 and 3821. These are returning regions, and you can watch some of the activity. Bam, right there's a little something. This region is actually growing as well. So as we watch some of this activity with these two regions, we know we have at least two more active regions that will end up being possibly big flare players and possibly solar storm producers. So expect, for you amateur radio operators, expect that solar flux to increase as well as that radio noise here over the next week. And potentially we will also have more activity and more solar storms. Now, switching to our moon, we are now passing through the third quarter phase on our way to a new moon. And by the 30th, the moon will be about 4.5% illuminated. So you night sky watchers, if you want to catch those dim objects in the sky, like, I don't know, maybe some aurora near the equinox, well, now is your perfect chance because this sky is a bit on the dim side. And now switching to our solar storm conditions and aurora possibilities over the coming week, we are anticipating the hit from that Earth-directed solar storm that's following that fast solar wind. So at high latitudes, NOAA is expecting major storm conditions, and we have up to about a 20% chance of a severe storm on the 26th, but things will calm down quite quickly because it's only a glancing blow. So by the 27th, things could be back down into active conditions, and then we will continue to quiet down after that. Now at mid-latitudes, well, the story's about the same. We're expecting minor conditions, but we do have up to about a 40% chance of a major storm. And again, back to active conditions by the 27th, and then things will continue to quiet down. Of course, we do have those new regions rotating into Earth view, and we could have multiple filament launches. So the back part of this forecast could definitely change very quickly. But aurora photographers, you should keep your cameras at the ready because we could get some more aurora this week. Now, switching to our solar flare and dayside radio blackout outlook over the coming week. Well, we're sitting well into the triple digits. We're sitting at about the 170s right now, and that's about where we'll stay. We've got some moderate noise on the bands right now. This is because we do have a couple big flare players in Earth view, and more are coming. NOAA's giving us about a 55% chance of an M-class flare at R1 to R2 level radio blackout, and about a 20% chance of X-class flares at an R3 level radio blackout, and that will easily last over the next couple days until those new regions rotate into Earth view, and I've kind of bumped up the levels just a little bit, not too much, but that does mean that we are watching that radio noise rise just a little bit as well as that solar flux, so radio propagation should remain pretty good on the dayside bands, but we could have more radio blackouts in store. And now as we switch to our radiation storm and polar aviation outlook over the coming week, everything is basically in the green this week. We're sitting at the D1 normal range for you aviators at flight level 360, and that is the S0 quiet range for everybody else. NOAA's only giving us about a 5% chance of an S1 to S2 level radiation storm. That might rise as we move through the 5-day because we have a few more regions that are going to be rotating to the west limb that we have to watch out for. But overall, everything is reasonably quiet. So you frequent flyers, and this does include aircrew and high-risk passengers, for the most part, we're all in the green, and we're likely going to stay that way. So the space weather this week has been a bit on the mild side, but activity is beginning to pick up. Now, we do have some fast solar wind that's hitting Earth now, and that's going to be followed by a solar storm chaser. And because of the equinox, that's going to allow aurora to come down to mid-latitudes. So you aurora photographers, you've already been getting a little bit of aurora sporadically at mid-latitudes. When that storm hits, it could really bump up the shows a bit. So make sure you keep your cameras at the ready. And now, amateur radio operators and emergency responders, well, things have been reasonably quiet. We did have that one big M-class flare a few days ago when that solar storm was launched, but since then it's been just low-level M-class flares, really not all that much to talk about. Now, activity may be picking up here in the next maybe 3 days as these new regions rotate into Earth view. Radio noise might also pick up a little bit, but it shouldn't be too bad, I'm hoping. So hopefully not too many big R3 level radio blackouts are in store this week, and you kind of can continue to enjoy the dayside radio bands. And now you GPS users, well, we do have, a bit of inclement weather right now, especially on the night side, because we do have some aurora that's dipping down into mid-latitudes, and that's likely going to increase over the next couple days as the solar storm passes through. But we're not having the huge R3 level radio blackouts on the Earth's day side. So that means that radio reception, or GPS reception rather, for you on dawn and dusk might be all right, but just stay vigilant, and on the day side, your reception should be pretty good. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Thank you, Tamitha. Excellent report there, and so glad that the report covers this weekend up until Monday. So it all is applies to current situation. All right. Now I'm going to run with this next article because we've only just got time to squeeze this in. This was a courtesy of Andrew of K3KIS. Thank you, Andrew. Oh, before I do, so while Tamitha was talking there, I managed to have a quick trip down to Tasmania and look at the Tasmanian Ham Radio Conference. So it is slated for November. Excuse me. Saturday 2nd, Saturday the 2nd and Sunday the 3rd of November is this Tassie Hammy Con. And I do have a little program here to show, the program guide, that's pretty much what I'm going to say, up on the screen. So you can actually see that Tamitha is a keynote speaker, keynote number 1 speaker for Saturday morning, and there's the time up on the screen there. So she's slated to do her presentation from somewhere after 9 o'clock. It doesn't say anything else. I gather that she's going to actually be there. So here's your chance to meet Tamitha in person. So I believe that she'll be actually in person down there. So that's the 2nd of November. So if you want to head off down to Tassie to the HammyCon, probably worth to get that sorted out now and get your plans ready so that you can actually do that. So there it is. It'll be good to catch up, actually. All right, now, quickly, because I'm running out of time now for this other article. Where do I start with this? This article is an interesting one. It's about a telescope that had been vandalised by an employee. It's called the Harlan J. Smith Telescope. It's a 107-inch, 2.7 metre telescope located at the McDonald Observatory in Texas, United States. The telescope is one of several research telescopes that are part of the University of Texas at Austin Observatory, perched on Mount Locke in the Davis Mountains of West Texas. The telescope was completed in 1968 with a substantial NASA assistance, and is named after Harlan James Smith, the first Texan director of McDonald Observatory. Smith was the observatory director for 26 years. Then around February 1970, the telescope was the victim of an act of vandalism. A newly hired worker suffered a mental breakdown and brought a handgun into the observatory, firing one shot at his supervisor, the worker, and fired the remaining rounds into the primary mirror. The holes effectively reduced the 107-inch telescope to the equivalent of a 106-inch telescope, but did not affect the quality of the telescope's images, only the amount of light that can be collected. So I'm going to run a little bit of video here, which is about dealing with this episode. And let me see if I can just find it here. I know it's just in here somewhere. There it is. Okay. So yeah, stand by for this. This runs for about 12 minutes and is interesting to listen to and watch. Thank you, Andrew. So this is VK3 Echo Kilo Hotel, courtesy of the YouTube website Astrom.
Did you ever hear the story of how the Harlan J. Smith telescope got shot 7 times? The world of astronomy can be a surprising place, with groundbreaking discoveries getting made all the time. But normally ground is the only thing being broken, and the only shots are images taken of the night sky. It's exceptionally rare for someone to actually attempt to attack a telescope. And yet, in 1970, that's exactly what happened. This moment could have spelled disaster for what was then the 3rd largest telescope in the world, which had only just been completed 2 years prior. What happened? Why did someone shoot through the glass mirror of an observatory telescope with a 9mm pistol at point-blank range? And how did a glass mirror of such impressive size deal with 7 shots from a gun and several preliminary strikes from a hammer? I'm Alex McColgan, and you're watching Astrom. Today we'll be taking a closer look at the only time in history when an observatory got shot. In 1963, the space race was just beginning. NASA was considering how best to visit the planets of the solar system as part of the US's goal to get ahead of the Soviet Union. It was a technical task that needed more information about those planets, so NASA started planning new telescopes that could image the heavens they'd soon be traveling to. Onto the scene came Harlan J. Smith. Smith was a driven man, described as softly spoken by his peers, who had a deep love of astronomy. He had just been made director of the McDonald Observatory, operated by the University of Texas and located in the mountains near Fort David. And in his first official act, he was able to persuade NASA to give $5 million to build a new telescope on his site. The project went ahead, and production began in 1964 and was completed in 1968. This was no small project. The newly finished 2.7 meter mirror telescope was, at that point in time, the 3rd largest in the world, weighing in at 160 tons, with light gathering capabilities 250,000 times greater than was viewable with the human eye. Usually, while the electronic components of a telescope can be changed out as technology improves, a telescope's expected lifespan is about 100 years, which is useful, as often observations can take decades to complete, and it can take 20 or so years for some known exoplanets to complete one full orbit, for example. Undiscovered ones could potentially take even longer. The newly built telescope would be something of a Swiss Army knife, but primarily would focus on spectroscopy. The mirror itself was made of fused silica glass, and while you might think that sounds easy enough to make, we create glass all the time, right? Fused silica is a special kind of glass that's made in a very particular, technically involved way. Producing the fused silica took almost 1.5 years, piece by carefully crafted piece, in a process of plasma torch hydrolysis using silica gas that required temperatures of 1700 degrees Celsius. And after the 1400 degrees Celsius process that fused its segments together was complete, just cooling the entire shape back down again to take its final form took another 2 years. That was all to create a mirror that had almost zero internal stresses and strains, perfect for the work ahead of it. Which is why it was so serious when, not even 2 years later, a man named Jack Hyde decided to try and take the observatory's telescope mirror out of commission. Jack was an instruments technician who had only recently come to work at the McDonald Observatory on the 1st of January 1970, and we don't completely know his motivations. He was in his 30s, had previously been employed at the prestigious Smithsonian Observatory at Massachusetts, and had travelled to Texas to work while his wife and 3 children went to live in Nebraska. McDonald Observatory was nestled up in the Davis Mountains, where its isolation and elevation meant it had little light pollution and less atmosphere to contend with. The nearest town, Fort Davis, was around 27 kilometers away, so all the staff tended to live on site. But such isolation and distance from his family may have taken a psychological toll on Jack. On top of that, hours were long. Observatories always want to be performing science as much as possible when conditions are right, which sometimes means technicians and operators could be pulling 48 or even 72-hour shifts. This isn't entirely unsurprising. Bad weather, too high atmospheric dust levels, or strong 100 km/h winds could call a halt to the telescope being used at all. And if you work in an observatory, you are likely passionate about astronomy. But when you combine the isolation from family with the grueling high-pressure hours, perhaps it sheds some light on why Jack Hyde, just a month after starting work, showed up to the telescope observatory at midnight with a hammer in his hand and a 9mm gun in his pocket. There are reports that Mr. Hyde had been drinking that night and was suffering from bad mental health. On the night of the 5th of February, most of the staff were in bed. The number of people manning the McDonald Observatory was never that high in those days, but only 1 telescope operator and 1 supervisor were actually in the building at the time of the incident. Mr. Hyde entered the building with relative ease. He worked there after all, and there had never been a problem like this before, so there was little security or reason to stop him. He saw the supervisor and fired a shot directly at him. Although the bullet went through the man's clothes, it thankfully passed through without hitting him directly and impacted the wall behind him. The supervisor ran off, understandably, and went to get help. Hyde then threatened the remaining telescope operator and got him to lower the telescope into a maintenance mode so the mirror was easily accessible. Hyde then entered the telescope and got out his hammer. He struck the mirror, expecting it to shatter. He was an instruments technician, which meant he usually dealt with the image capturing camera and equipment at the bottom of the telescope. He was thus unfamiliar with the properties of the glass mirror and was surprised when his hammer did not smash the 4.5-ton mirror, but instead bounced off, recoiling and hitting him instead. He did, however, manage to chip off a pear-shaped dent from the mirror, but that was about it. In frustration, Hyde pointed his gun at the mirror and unloaded all 7 remaining shots in his clip. Each one lodged into the mirror, but did little more than penetrate a few centimeters. The process of making the mirror had involved taking layers of glass and fusing them on top of each other. This was due to the scarcity of the fused silicon material, and because of other limitations of the technology at the time, it was easier to make smaller pieces and fuse them together. But ironically, this process had created a material similar to laminate glass. Combined with its thickness of 31.8 centimeters, it was essentially bulletproof. By this point, more staff arrived to restrain Hyde, holding him until the local sheriff arrived. Unfortunately, when the sheriff looked at the mirror, he mistakenly thought that it was completely destroyed due to the large hole in its center, not realizing that the central hole was supposed to be there, and it was just the smaller bullet holes that were the actual problem. Newspapers began running headlines about how the telescope was destroyed, and Harlan J. Smith, the director, had to publish an official report telling the astronomical community that there was actually nothing to worry about. Ironically, Hyde's shots had mostly missed the vital part of the mirror. To an untrained eye, all parts of a telescope mirror looked like they served the same function. However, the portions of the mirror near to its center are actually largely unused for resolution, as they are shadowed by other components, and perhaps are only used for a little light gathering. It's the area near this ring here that gathers the light used in imaging. Fortunately, this means that only 3 of Hyde's shots actually hit a critical area of the mirror. And given that those small centimeter-wide holes only contribute to a small fraction of the mirror's total surface area, Mr. Smith was able to report that the bullet holes reduced the light collecting efficiency by about 1% and introduce a very small amount of diffraction. Not only was the telescope able to survive the attack, it actually came out almost completely unscathed. Mr. Hyde initially faced the prospect of criminal charges, with a potential jail sentence of 2 to 20 years. But when Director Smith learned about the mental health problems Mr. Hyde had been facing, he decided not to press charges. Instead, he elected to get Mr. Hyde into a mental institution and tried to get him help. It was a kind act, and an indication that the director didn't harbour any actual ill will towards Hyde, perhaps because fortunately, no real harm had been done to either man or machine. However, when he was eventually released, Mr. Hyde did not return to work at the observatory. The University of Texas engineers responsible for maintaining the mirror didn't need to do much to repair it. Using a small drill, they bored out the bullets and smoothed out the holes to prevent any further cracking. Then they simply layered the reflective surface back on and called it good. To be fair, nothing further was required. The Harlan J. Smith telescope still bears these bullet holes to this day. The telescope went on to have an illustrious career. Images it captured helped inform the plans for the Voyager missions, and it has also made huge discoveries in the field of exoplanet research. Back in an era when people had no idea exoplanets were even out there in any significant number, the Harlan J. Smith telescope searched the skies for these astronomical bodies, helping confirm that they are so frequent that every star might have at least one. So, the science community is grateful that Mr. Hyde didn't manage to carry out his objective at the time. Science would have lost much without this telescope, which later was named the Harlan J. Smith Telescope in honor of the director who had built it. But fortunately, it has suffered little more than a few battle scars from that night over 50 years ago that it can show to curious observers like you and I. And to be fair, when it comes to battle scars, it still has an easier time of it than space telescopes like the James Webb that face ever-present threat of micrometeors striking its mirrors. So, how does a telescope deal with a 9mm pistol? Pretty well is the answer, and it's all thanks to excellent engineering and about 4 tons of bulletproof glass. The more you know. A big thanks to Coyne Gibson, the McDonald Observatory's present-day manager of observing support, who was able to speak to me and provided me with a lot of these photographs. You helped make this script possible. Our solar system is...
There it was. Thanks to Astrom for that. And if you visit the YouTube site Astrom, there are many other interesting videos that he's produced over the years, and I'm looking forward to having a bit more of a check of what he's got available. So excellent stuff indeed. But how about that, eh? Oh dear, and those bullet holes still exist in that mirror to this day, but there it is. All right, it's 5 past the hour, so I'll pick up spaceweather.com and see where we go with that latest from spaceweather.com. We have a picture of the sun here, the current disk of the sun, which we shall bring up. There it is. And the solar wind is currently 340.5 kilometers a second, with a density of 2.46 protons per cubic centimeter. The current disk of the sun has several sunspots on its surface. If we were able to check the sun out right now, that's how it would look. The current sunspot number is 189. The radio sun, measured at a wavelength of 10.7 centimetres, is 181 solar flux units. The aurora, southern aurora over Antarctica, looks a bit like this. Where is it? I did take a picture of it, but I didn't move it across. Okay, so let me just go to my image category, and I think that's it there. We've got one from last time still sitting in there. I think it must be this one here. Okay, so this is the current image of the auroral glow over Antarctica. And as you can see, there is an extended ring towards Tasmania and the mainland, but it's only about a 50-50 chance of seeing anything at this stage, so it's nothing to go out right now and look for. I don't think you'll see anything unless you're down near the shoreline, coastline. But it is happening nevertheless. The rest of space weather, we have there is a few coronal holes on the disk of the sun facing us right now. Looking at the picture there, and where is our KP index? Planetary K index is currently 2.33. KP is equal to 2.33, and it's considered quiet. The 24-hour max KP figure is 3, which is also considered quiet. If you'd like to listen to WWV on 10 megahertz or 15 megahertz, they will give you updated planetary K indexes as they get updated. What else? But otherwise, they're saying that it's all quiet, probably. Yesterday, a CME was expected to hit Earth. It missed, and no sunspots are actively flaring at this point. As a result, today's space weather is expected to be all quiet, probably. That's today. The other thing that spaceweather.com spaceweather.com comments about, oh my god, spaceweather.com is reporting also on a comet which is visible in the northern sky right now, and here is a picture of this. This would be one to see if you are up there at the moment. It was visible in the southern hemisphere for a little while, but it is now becoming a northern sky object, and that's what it looks like at the moment. We actually have, there's actually some interesting footage here taken of it approaching the sun, and let me just bring that up, and that should play. Yeah, it's playing. This is very interesting footage that you can see. Leading observers estimate that the comet's magnitude is about plus 2.9, visible to the naked eye barely, apparently, despite the morning twilight. And in this image here, what you're seeing right now, it's actually a simulation. Okay, it's a simulation showing a massive increase in brightness during the second week of October. At that time, light from the nearby sun will be scattered by comet dust, amplifying the comet's brightness if the most optimistic predictions come true. So it's predicted to actually brighten in the first few weeks of October. And this image you're seeing on the screen is purely a simulation, of course. I thought it might have been real footage there, actually. It just looks so real. So, yeah, I'm avoiding the pronunciation of this comet. It's just one I can't get my tongue around. It's called Comet Atlas, otherwise. It's designated as C/2023A3. Atlas C/2023A3. Comet Tushinshan is the best way I can pronounce that. Tushinshan, perhaps? I don't know, something like that. Anyways, there it is. All very good stuff. Down the list, of course, we come up to... I haven't picked up the long screen here. I'm just coming up to my camera. There it is. This camera's on a battery at the moment, so I'm expecting it to go flat any moment. So, having said that, the latest near-Earth asteroids, potentially hazardous asteroids. This figure has not changed for weeks. Potentially hazardous asteroids, which are space rocks that are larger than approximately 100 meters, that can come closer to Earth than 0.05 astronomical units. But none of the PHAs, none of the known PHAs, is on collision course with Earth. As of September 27, 2024, there are 2,349 potentially hazardous asteroids, including the one that's becoming our second mini-moon for a few days coming up from the Sunday. A few days for a few weeks, actually. And there it is. I think I shall finish up on that. And I hope you enjoyed the reports tonight. The video of Comet McNaught I took, the Timothy's report, and also the interesting footage there of the sabotage on the Harlan Smith J telescope. Unbelievable. I think that's all I have to show. Just making sure I've covered everything. I think that'll be it. So, you've been listening to Clint Jeffrey, VK3CSJ, on behalf of the Astronomical Society of Victoria's official call sign, VK3EKH, on this 27th of September. And I wish everybody who's so mad crazy about football that their favourite footy team wins tomorrow. I'm actually barracking for Brisbane, so why not? But I'll be there watching the TV. Traditionally, the TV runs on the grand final day, so it'll be going somewhere in the background. Let me just quickly check my email before I go across to the 80 metres. We've had only 3 emails, Andrew, John and Stephen. Thank you, Stephen, for your email. You're probably asleep by now. And I haven't checked my chat room out. We've got only 3 stations watching the Discord stream as I speak, but the chat room, let's see how active that's been. Kim is there. G'day, Kim, VK5FUSE. Steve, you are there, VK3SPX. Actually, this is from last week. That's from last week because he's saying, I hope you're better soon. So, where is all the chat room? Okay. I suppose people thought I was going to be here tonight. Or maybe it's the footy. Maybe everybody's still glued to the screen. I don't know. It doesn't matter. All right. We'll go across to the radio and to see if there's any stations wishing to check in on this day. This is VK3EKH. Okay, I have to pull my headphones out for this to work, I think. Hang on a sec. Oh, how different that is. Headphones off. All right, VK3EKH listening on 3541.
VK3 Golf Lima. VK3 TJ.
All right, that's a good check-in. 2 stations. Dear, VK3GL, VK3TJS. Anybody else? All right, VK3 VRS. All right, that does the list. All right, to you there, Grey Boy. VK3 it's GRL. Where did I get GRL from? VK3 GL, VK3 CSEKH. Sorry.
Oh, gee, you're all muddled up. VK3 EKH, VK3 GL. Now, I haven't had GRL now for. Oh dear, I reckon it's getting on to nearly 20 years, so I don't know where that came out of the archives. Anyway, good evening to you there, Clint. Good evening to Jack as well, and a very good evening to Richard as well. Good signal and all noted tonight, Clint. A good broadcast. I was able to watch a fair amount of it on the Discord channel and listen to it, but sadly interrupted a little along the way with what was happening with work. which is a normal Friday night for me, of course. Now, I wonder whether or not the lack of people being on air tonight for the check-in has got anything to do with the fact that it is public holiday and they're probably doing other things. And the other thing, whether or not they were watching the NRL, because that was on tonight. That was the only game that was on tonight, because the grand final's on tomorrow. You're probably aware of that anyway. Some good articles there tonight, Clint, and I'm surprised that if Tamitha's coming down to Tasmania, if that's actually confirmed, that you're not going down to Tassie to catch up with her or check out whatever's happening down there at the conference. So I'm a little surprised about that, but maybe it just doesn't fit in with the agenda. That weekend, I think the dates that you mentioned was the Saturday and the Sunday. Well, of course, the Monday is the Monday before Cup Day, so you'll have, most people try to make a bit of a long weekend out of that weekend. Nothing to really report this way. As I said, generally pretty good, and I caught up with a majority of what you had on the broadcast. The Space Weather woman's broadcast there, and what she said was indicative perhaps of how the bands have been. I have been listening around a little bit on 10 metres, and 10 metres for the last probably 3 days has been pretty much dead, absolutely dead. It was good at the start of the week, it was pretty active, but this latter part of the week has been absolutely dead. Usually we hear the United States in it coming through, but there was nothing much at all in the latter part of the week. But running up to that, it was actually pretty good, because I think I did work a couple of stations into Europe and a station in Ireland and that sort of thing the other night. That was earlier in the week, of course. All right, back around to you there, Clint. Thanks very much for the broadcast as always, and good evening to everyone else who might be listening. VK3EKH, VK3GL.
Okay, thanks, Graham. VK3GL, VK3 EKH returning. Excellent stuff indeed. Good signal from you tonight, 20 over, and the band's nice and quiet tonight, so doing very well indeed. Okay, yes, I just ran the program guide for the Hamicon up on screen again, and look, no, it takes a lot for me to decide to do anything like as grand as a trip to Tasmania. So yeah, if actually, if I headed down that way, I'd certainly kill two birds with one stone, sort of thing, because I would like to visit the Grote Reba Museum, down at the it's all part of the radio telescope down there at Tasmania University. They've got a special museum for Grote Reba, one of the pioneers of radio astronomy. He ended up living in Tasmania for quite a few years there before eventually passing. So that'd be really interesting to see that museum, and maybe if I was to key it up properly enough, I might be able to actually key a tour of that telescope, but that's a bit of planning, and no, not at the moment. Nevertheless, look, they'll probably video the conference. There'll probably be cameras running, so one way or another we'll get around to seeing whatever's happening down there, I suppose, during this conference. And you're right, it's that weekend, isn't it? Melbourne Cup weekend, so I've got the whole weekend, Monday off as well, so it could have potentially have been a trip down there, but that's out of my comfort zone. Anyway, alright, fair enough. Thanks, Greg, and thank you for the report and all that. Okay, it's across now to Jack, VK3TJS in Shepparton, VK3EKH.
Yeah, VK3EKH, and the group is VK3TJS. Good evening to you, Clean. Good day to Graham, and the other station, I didn't write the name, and anyone that's listening. And yeah, good broadcast, good signals, probably about done about 20 over most of the time. I had a bit of a problem with Discord. The screen has frozen, but it could have been my end. I don't know. I just refreshed it and it went back again. Interesting about that simulation of the comet. That was quite good. And you mentioned Aurora as well. And we've had I've seen some good pictures of that probably a week and a half ago or so from Shepparton. Some people took it. So yeah, it was quite good. I can't boast about all the contacts Graham did, but yeah, it's just been working, and I can only use the radio pretty much in the evening. But I took opportunity of a holiday today, or public holiday, and done a bit of maintenance here and there. That was quite good, and the weather was beautiful in Shepparton, so it was terrific. Thanks again for the broadcast. Hopefully you're reading me okay. And I'll catch you up next time, VK3EKH and the group VK3TJS. Thanks, Clint.
Yeah, thanks, Jack. VK3TJS, VK3EKH. Good signal coming in from you too. A little bit of the QSB, but the signal came quite nice, loud and clear. Thanks for the report. And yeah, I think tonight's series of little articles was quite good with the associated video. Made it more interesting too. So yeah, but I apologise for not being around last week. Again, there was just a couple of things that were tying me up. So but I managed to get here tonight. And I think Graham was right. It was probably the other football mob on the other channels that were probably keeping people away from the radio as well. Maybe not. Anyway, all right. Thanks, Jack. It's across to Richard, VK3VRS. He's a local station. And let's see how he goes on 80. VK3VRS, VK3EKH.
VK3EKH, VK3VRS. Long time listener, first time caller. And on this band anyway. Good evening to everyone that's out there. I'm not much of a HFer, so I just thought I'd put in a call. There weren't many call-ins, so I thought I'd just add my call line to your list. Clint, it came through no problems on the repeater, the ATV repeater. Discord was fine. I didn't check YouTube, but I'm assuming that YouTube was running okay. I was a little bit late here, only because we were finishing watching Aquaman 2. So on I think it was Netflix. But anyway, so Friday night movie with the wife. So yeah, but good report. It'll be interesting to see if Tamitha actually does turn up in person in Tassie, or whether it'll just be over the internet. So that could be the other possibility. So time difference would make it very interesting for her. But yeah, it could be fun. Anyway, that's it for me. And yeah, like I said, first time caller, long time listener. 3EKH, 3VRS.
Audio. I keep winding my audio down when I do that. Sorry. Thanks, Richard. VK3VRS, VK3CSJ, EKH. Do you have your 80 metre dipole up, or is it still hanging down a little bit?
No, it's up, but one side's down, that's all.
Okay, all right. Yeah, just over the 9, probably about 5, peaking 5 over 9 here, so signal could be definitely a lot stronger, but I suspect that's just because you don't have your dipole out nice and up in the air. And that's all right, that's no problem. Graham's hearing you, so you're not doing too bad. But acknowledge that you're not much of a HFer, so that's fine. But you know you got to start somewhere. Yeah. Anyway, all very good. Okay. If there's nobody else, I'll just quickly check. VK3 EKH listening for any other stations.
VK3 KH2 responding to VK3 EKH group. Good signals tonight. I'm listening on 3541 and watching the video. I get sharp tiny small video, and so it's and I lose the audio for a short time each time I play. Listen on 3541 and watch the video. I can tolerate the interruptions in the video. Okay, thank you. Missed you last week. VK3 KH2 listening.
Thanks, Bill. VK3KH2, VK3EKH. Good to hear you on the band. You're not super strong, but you're there. You're basically 5 and 9. So, but thanks for calling in. It's good to hear you. I know you don't. I know you're always generally listening or watching in the background, and you don't always report in, but that's fine. But thanks for adding to the list, tonight's list. So thanks, Bill. Good on you. And yeah, I don't know about the video. Look, I haven't seen any dropouts here. Certainly the video via the television repeater was fine. Discord should have been fine, and I haven't seen any dropouts on the YouTube side. I'll go and check that out a little bit later on when I stop streaming, just to make sure that things did come across okay. All right, one more listen. This is VK3EKH on 3541.
Quick comment, Clint.
Go ahead, the station with the quick comment.
Just have a look over your right shoulder. You've got a pussy that keeps licking itself.
Yeah, that's my little Kiska. Yes, Kiska. Yes, kiss, 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 kiss.
Well, it's done its cleaning now, I think.
That's I'm taking a leaf out of Ian VK3QL's production book. She's my director, producer, and she's just keeping an eye on things from a key point in the shack there. Kiss! Kiska! Kiss, 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 kiss. Kiss, kiss, kiss. Oh, now, see, now I've disturbed her. She's, Kiss, 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 come here, come on. Kiss, 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 come on. She won't allow me to pick her up. She's one of those cats. Anyway, alright, this is VK3EKH, your official station for the Astronomical Society of Victoria, bidding everybody a very pleasant good evening. May your footy team win tomorrow. Have an enjoyable weekend. I think weather-wise it's going to be a very nice weekend, and we'll catch you all next Friday to do it all again with some more interesting articles that I actually held over one tonight, which I'll continue on with next week. So yes, this is the new camera. My old JVC camera is this one here. Oops, that one there. This is currently running off a 12-volt supply, and this is a newly acquired JVC camera, but they're both the same. They're exactly the same model camera in the same vintage, and that's basically what I was after, was two identical cameras that could give similar images. I must stop doing that. Alright. Okay, we shall conclude. This is VK3EKH concluding on 3541 kHz and one or two of the digital streams at the same time. Cheers everyone, thanks for making it worthwhile. Is that you, Dallas? Thanks, Dallas. You're in the log. Yeah, go ahead, Dallas. VK5 Kilo Kilo Tango, VK3EKH. Go ahead.
India Alpha November, Ian from 2 Worlds here. Clint, private 9 plus 20 here most of the time, over.
Oh, sorry, Ian. You have to forgive me, I'm getting old. I knew that, I did know that. Thanks, Ian, for calling in. No worries, thanks, mate.
Yep, no worries, cheers for now, VK time PKT clear.
Cheers, Ian. Oh, it's always getting someone's call sign mixed up.
Oh, thanks for that there, Clint. Very nicely done. Just while you're there, well, when you finish up, give us a call back. I'll have a brief word to you. But when you started talking to the cat, my dog was sitting on the floor half asleep, and all of a sudden I've got this cold nose up against my leg. So he's heard you on the radio going tiss like that, and he's decided to come over and investigate. Now I don't know whether he thought it was me making the noise or what it was, but obviously he was attracted by that noise and come over to investigate. Otherwise he would have still been sound asleep on the floor. So there you go. Anyway, alright, give us a call back when you've finished your wrap up. VK3 EKH VK3GL.
No worries. All right. Yeah. Well, there it is. Okay, I'll call you back in just a tick. VK3 EKH. All right. This is VK3 EKH concluding on the digital streams. Thank you for watching. Anybody who was watching YouTube, send me a report on the VK3EKH@gmail.com. VK3EKH@gmail.com. And I'll send you an email back saying hi, thank you for the report. Meanwhile, I shall close the streams down and we'll see you all next week. So thank you for watching and putting up with my bilge. Where's my colour bars? Do I have colour bars? Oh yes, I have some colour bars here. Alright, cheers everyone, take care, bye for now.